Hello, everyone, and welcome back. Today, we are going to be starting a new topic called TensorFlow. So, now what is TensorFlow? It is a library that is used in machine learning and it is an open source library for numerical computation. Now, it is used in many programming languages such as Python, R, C++, and it provides a user to build a data flow graph to make the data understandable. So you can say TensorFlow is just a tool to help us understand the data more and work more efficiently with it. Now, in the TensorFlow Python deep learning library, a tensor is an array that represents the types of data. So, unlike a one dimensional vector array or any two-dimensional matrix, tensor can have n dimensions, where n can be any type of number. So now applications of it. It works with voice and sound recognition. One of the best known use of TensorFlow is sound-based application. With the right data source, the neural networks can understand the audio signals. These are voice recognition, voice search, sentiment analysis, and fault detection. One example we use in our daily life is the Google. Text based application. Other popular uses of TensorFlow are text based application, such as sentiment analysis, which is CRM and social media, threat detection, social media and government, fraud detection, which involves insurance and finance, and language detection is also one of the most popular uses of text based application. And last but not least, we have image recognition, which is mainly used in manufacturers of social media. Telecommunications, cell phones, image recognition aim to recognize and identify the people and objects in images. So, we want to understand and identify just like in our iPhones, the face detection. So now they want to understand the content of the image, the detection of the movement, the vision of the machine, and the grouping of photos. They can also be used in automotive industries of aviation and health and the context. So now we're going to be moving on to the coding part. We're back to the coding part. So first of all, we're going to import TensorFlow as TF. Here we will be nothing doing with CV, which is computer vision. So we're going to import numpy as np, which has our numpy arrays, and import matplotlib.pyplot as plt, which means we're also going to print graphs. So we have our variable over here, fashion mnist. So tf.caros dataset and fashion.mnist. So this dataset is actually already stored in TensorFlow. We're just going to activate it. And we have our train images, train labels, test images, test labels, and they're all equal to fashion mnist load data. So we have our class names. Class names means what are the things inside the data set. We have our t-shirt, top, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, ankle, boot. So we have our very big data set and we want to classify these. So we have plt.figure. We want to show them the train images. We have our color bar and we have our grid, which is false. There's no grid. And now we're going to show it. So we're going to also show the PLT figure. The fixed size means the size of the figure is going to be 10 by 10, which means 100. And for I in range 25, we're going to repeat this 25 times. We have subplots 5, 5, I plus 1. We have x ticks and y ticks. And we have still no grid. And now we're going to show our train images, CMap, and plt.cm binary. So PLTX label, class names, and train labels are going to show it. So after our loop is done, we're going to show our another graph because we have a lot of images to sort. So we're going to have our model tf.caras sequential. So we're going to flatten it, and input shape is going to be 28 by 28. We're going to have our layers, which is going to be dense, is 28, and activation is going to be reloop. This is basically just the name, so no need to worry about that. And tf.caras is going to be dense. So now we're going to compile, which means optimizers asm. We're going to loss, TF keras, losses, and the sparse categorical cross entropy. This is just a name. From the logics is true. So we're just, making sure our data set is accuracy, which I said over here. So now we're going to fit in the train images, the train labels, and the epoch. Epoch is the time you want to train our data set, our computer, so it becomes more and more accurate. I'll keep it as 2 for now. So we're going to have text loss, text accuracy, the model evaluation, text images, and test label, and the verbals, which is going to be 2. Now we're going to print and test accuracy, which is going to be the test accuracy. So if it's like 99 or 97, it's going to be that the test accuracy is 99. So we have a probability model, and we have the tf-keras sequential model, and we are going to do our function, which is tf.keras laters dot softmax. Now we're going to prediction, which means here we're going to predict it. Probability model, predict, test images. Now we're going to have np, which means our numpy array argmax predictions. We have our def plot image, which is our prediction array, and the true label img. So true label img is equal to true label imgi. This is basically a code that we're going to do, and we still do not have a grid, so we're going to keep it as false. And we have our x ticks and our y ticks over here, as you can see. We have our plt im show. Cmap is going to be plt cm binary, which is basically the color of our graph, so what we want it to be. So we have our predicted label, argmax prediction is array, and then we have if predicted label equals to true label, then color should be blue. Else, if it's not equal to, then its color should be red. So we have our X label, we have this code over here, as you can see, this is just for the activation. And we have format, class names, predicted labels, 100 NP, max, prediction array, class names to label, and color is equal to color. So as you can see, we're now plotting our value array. We have predictions array and true label. We have our true labels is equal to true label I. So you can see they both are different, but they're both equal to each other. We still don't have the grid, so it's going to be false. And x ticks is going to be range 10. Y ticks is going to be no. And then with this plot we have over here, it's is equal to plt bar, range 10, predictions array, color, this code over here. So as you can see, this whole code over here is just for our graph and how accurate our model is. We have our ylm and predicted label. Then we have this plot unpredicted label set color red. This plot true label set color blue. So you can say if it's predicted, then it's gonna be red, and if it's true, means it's true, it's gonna be blue. Now we're just going to make our final arrangements for the figure. It's gonna be 6 by 3. We have 1, 2, 3, 1, 2, 1 for the subplot. Plot image is going to be predictions, test labels, and test images. Subplot is going to be 1, 2, 1. And plot value array is going to be predictions I test label. And now finally we're going to show our results. So as you can see over here, this is our image. And if you scroll down, this is our whole data set of what we just classified. We have an ankle boot, then we have the sandal, a sneaker over here, then a trouser. So we coded for trouser. So we're going to check how many trousers are there and whether the computer identified it correctly. So you can see we have ePort 1 out of 2 and we have 2 out of 2. As you can see in the first one, the loss is 3.3 and the accuracy is 6933. Here the loss is less, which is 0.6994, and the accuracy is more than previous. So now, as you can see, trouser is 100%, which means that the computer has identified it. Thank you so much for watching, and I'll be seeing you in my next